Mount Merapi is once again producing a series of pyroclastic flows which are making the news. The pyroclastic flows shown here traveled about 3 kilometers from its summit. However, this isn't too unusual, as the volcano has been almost continuously erupting since 1548. This video will discuss this active volcano in Indonesia and mention what its future hazards are. Mount Merapi can be found in the central west part of the island of Java. Specifically, it is 56 kilometers south of Semarang. This volcano exists due to the subduction of the Australian tectonic plate underneath the Sunda plate. The Australian plate is denser than the crust of the Sunda plate, so it is forced downwards. The oceanic crust from this tectonic plate then melts and migrates upwards until it erupts on the surface, creating a volcano. Mount Merapi began forming 138,000 years ago when a series of eruptions created the Turgo Hill. The eruption at this hill was largely effusive in nature and likely produced several tall lava fountains. 3,000 years later, another volcanic hill formed a kilometer to the east, which is called Ploengan. The next period of volcanic activity began 109,000 years ago and created Mount Bibi. The eruptions from Mount Bibi were slightly more explosive in nature than those which occurred during the previous period. The subsequent period of volcanic activity began 30,000 years ago and formed a new volcanic cone on top of the lavas from Mount Bibi. This volcanic cone was referred to as Old Merapi. For the next 22,000 years, this cone represented the summit of Mount Merapi. This changed when the summit was destroyed in one or more massive debris avalanches which caused a portion of the mountain to slide off to the southwest. The mechanism of these events was likely similar to the 1980 eruption of Mount St. Helens in the United States. The final period of volcanic activity began 6,700 years ago and continues to the present day. This period has featured more than 100 distinct eruptions of primarily andesite lava. These eruptions helped to create a now 2,910-meter tall mountain. Eruptions from this modern volcanic edifice are often highly explosive in nature. One of the largest eruptions to occur from this mountain in the last several thousand years took place in 1180 BC. This eruption produced at least 100 million cubic meters of ash and tephra. Over the past several hundred years, eruptions at Merapi have followed a rather predictable pattern. Initially, an eruption produces lava near the summit of the mountain. This lava then slowly builds up over time, forming a plug which blocks the main summit crater. Hot gases and additional magma get trapped underneath, which build up in pressure. Once the pressure reaches a certain point, these gases and lava are forced out of the volcano in a large explosion. These explosions and the associated dome collapses are the cause of the frequent and deadly pyroclastic flows at this volcano. To understand the extreme extent of hazards from Mount Merapi, let me remind you of a recent large eruption which occurred in 2010. During this eruption, the volcano produced a long-distance pyroclastic flow which traveled 13 kilometers from its summit. The eruption also produced bombs of lava, lahars, and caused 30 centimeters of ash to fall on a village 15 kilometers away from the mountain. Although most eruptions are 1 or 2 orders of magnitude smaller than the 2010 eruption, there is still an extreme danger posed by their effects. For example, pyroclastic flows which travel a kilometer or more occur several times a year. These are essentially impossible to predict in the short term during eruptions, which puts the lives of everyone who remains nearby in jeopardy. I personally would recommend a permanent 5-kilometer exclusion zone around the mountain, which increases to 15 kilometers towards the southwest of the summit. However, 49,000 people live within 5 kilometers of Merapi. Moving large numbers of people is not an easy task, but perhaps showing them the scientific data might work. For example, this map shows where pyroclastic flows have reached between 1911 and